Dear children, now we discuss about exercise 7.9, first question. In the first question, 5 subdivisions having. In that subdivisions number 1 consider. What is the question? Find the asymptotes of the following curves. Find the asymptotes. Asymptotes means horizontal asymptote, vertical asymptote and slant asymptote. Having or not, we check that. So what is the meaning of asymptote? Already told you. Limit x tends to a f of x, it reach to infinity, then x is equal to a1 asymptote. So this is the vertical asymptote. If limit x tends to infinity, f of x is equal to some value a, then y is equal to a and another asymptote. So y is equal to a means horizontal asymptote. And about slant asymptote, f of x is equal to h of x by some g of x. So both are polynomials. This is also polynomial. So hx degree and gx degree both are, suppose this degree m, this degree n. So m greater than n, then slant asymptote is there. Slant asymptote is there. So now we check this. So it is f of x where it is infinity. What is the x value? Suppose x square minus 1 value is 0. So this is going to infinity. So x square is minus 1. Suppose taken 0. X square is equal to 1. X is equal to plus or minus 1. Okay. There are asymptotes. So we check the limit x tends to 1 plus 1 positive, 1 above value. So what is the f of x? Limit x tends to 1 plus f of x is the x square by x square minus 1. Now we substitute 1 plus 1 above. So compared to this 1 value, here 1 above and square. So compared to 1, this value bigger. That's why positive, denominator positive. Something by here 0, positive infinity. Positive infinity. After that, limit x tends to 1 minus f of x. Limit x tends to 1 minus x square by x square minus 1. So here 1 minus less than 1. Less than 1 means 0.9 like that. So 0.9 square, 0.81 below 1 compared to 1, this is the below 1. Negative coming here. So it is the negative infinity. Therefore, x is equal to 1 is a vertical asymptote. Vertical asymptote. After that, about minus 1. Limit x tends to minus 1 plus consider. Minus 1 plus. Minus 1 plus what? Minus 0.99 like that. So consider 9. 0.9 whole square is the 0.81 compared to 1 less than 1. So f of x is here. Limit x tends to minus 1 plus x square by x square minus 1. This is equal to, so plus 1 plus minus here. So compared to this, this is the little value. So it is negative coming. Yes, minus 1 plus means minus 0.9. Minus 0.9 square is the 0.81. Minus plus 8.1 something coming. So compared to this value, it is the less. So negative coming. That's why infinity negative. Next, limit x tends to minus 1 minus check f of x. Limit x tends to 1 minus f of x is the x square by x square minus 1 is equal to here 1 minus minus 1 minus. So left side minus 1.1 square how much 1.21 like that coming this value. So compared to this is the big value. That's why positive infinity coming. So now therefore y x is equal to minus 1 is a is also vertical asymptote. Okay. After this we check the horizontal asymptote is there or not. So we check here f of x is equal to x square by x square minus 1. So we check the limit x tends to minus infinity f of x. So this is also written as in the case of infinity we divide with maximum power x square. So x square divided with total function x square by x square 1, x square by x square 1, here 1 by x square. This both are equal functions. Now we substitute minus infinity here, minus infinity square, this is 0, 1 by 1 minus 0. That means 1 by 1 minus 0, it is equal to 1. Same, limit extends to plus infinity. F of x what coming? Here 1 by 1 minus 1 by infinity, this is 0. 1 by 1 minus 0, 1. It is totally 1 coming. So if it extends to infinity, y value 1 coming. So y is equal to 1 is horizontal asymptote. Horizontal asymptote. Horizontal asymptote. Okay. So now next, slant asymptote is there or not? So here numerator degree x square, denominator degree x square, 2 and 2. So here numerator degree is equal to 2, denominator degree is equal to 2. So that's why numerator degree is not greater than by denominator degree. That's why there is no slant asymptote. There is no slant asymptote. This function graph. Suppose here x is equal to 0, then f of 0 is equal to 0 by 0, 0 coming. So this curve passes through the origin. X is equal to minus 1, x is equal to plus 1, horizontal asymptotes, and y is equal to 1 vertical asymptote having so draw the graph. This is the x-axis, y-axis. This is the negative x-axis, negative y-axis, origin. So here x is equal to 1, here x is equal to minus 1, here y is equal to 1. So x is equal to minus 1. This is the vertical asymptote. Here also x is equal to plus 1, this is minus 1. This is also vertical asymptote. After that, y is equal to 1. Y is equal to 1 also, one horizontal asymptote having. This is the y is equal to 1, this is the x is equal to 1, this is the x is equal to minus 1. Three asymptotes are there, no slant asymptote here. Now, at 0, f value 0. So it is passed through the origin. After that, this curve at minus 1 and plus 1. So minus 1 minus, it is the minus 2, minus infinity coming, this value. This is the graph. And at the same time, it is a reflection to this also. Plus 1 minus, so it is the infinity. Plus 1 plus it is this side is infinity, this side infinity. So this is the one curve. This side, this above infinity, this left side also infinity. Here another curve, -1 plus infinity this side. So 0 having -1 minus this side infinity. It is passes to the origin and touch at infinity points. This asymptote meaning what? It touch at infinity point. So this curve touch at infinity point. This curve also touch at infinity. This curve also touch at infinity. This side also at infinity. So this side infinity, this side infinity. Positive infinity. This is the positive infinity. This is positive infinity. This is negative infinity. This is a downward. It is a negative infinity. Here also negative infinity. So we consider the some values. So one about 2 values you take, some value coming here. After 3 take another value. So here f of 1 infinity 1 plus. After that 1.1, 1.2, 1.3, 2 like that you take values. Little inwards decreasing like this. Any value. And also here also check -1.1, 1.2, 1.35, -2, -2, -3 like that. So if you value negative sides given, it is going to decreasing curve. In this also same 1.2, 1.3, 1.5 take this value decreasing downside up to infinity according to values. Subdivision 2, f of x is equal to x square by x plus 1. What we find asymptotes. So here f of x, x square by x plus 1, where it is the infinity. Suppose this is 0, it is f of x is infinity. So if x plus 1 is equal to 0, x is equal to -1. At -1, this is the infinity. So put limit x tends to -1 plus f of x what coming? Limit x tends to -1 plus f of x is the x square by x plus 1. So here 1 plus -1 plus -1 plus means minus 0.9 like that coming. So compared to this is the least value. That's why it is the positive infinity coming. Next limit x tends to -1 minus f of x is equal to limit x tends to -1 minus x square by x plus 1 is equal to -1 minus. So left side -1.2 like that. So here compared to this is the -1.2. So negative coming, negative infinity. So x is equal to -1 is vertical asymptote. Vertical asymptote having. So any y is equal to something, otherwise horizontal asymptote is there or not, to check. Limit x tends to infinity, f of x tends to x square by, limit x tends to infinity, x square by x plus 1. So this is infinity by infinity, so it is not defined, Otherwise this is also simplified by x square by x square, 1 x by x square, 1 by x square, 1 by x plus 1 by x square, 1 by x square. This 0, something by 0 infinity coming. In this way also infinity. So there is no horizontal asymptote. No horizontal asymptote. No horizontal asymptote. Next, we check the slant asymptote. So here numerator degree 2, denominator degree 1. So greater than numerator, here numerator degree is equal to 2, denominator degree 1. So here numerator degree greater than denominator degree. That's why there there is slant asymptote. Slant asymptote. So how we find the slant asymptote? So that given function x square by x plus 1, we divide with x plus 1. Division method, x square, otherwise x square by x plus 1. Here put x square minus 1 by x plus 1. This is written as x plus 1 into x minus 1 by x plus 1. This term cancelled and x minus 1 coming. So this value y is equal to x minus 1. So y is equal to x minus 1 is the, here put plus 1 and also minus 1 plus 1 cancel. So here x square minus 1 by x plus 1 by x plus 1. So this is x minus 1 into x plus 1 by x plus 1. Here 1 by x plus 1. X plus 1 cancelled. So x minus 1 plus 1 by x plus 1. This is the f of x. That means y. So here asymptote where to where, here to here. Y is equal to x minus 1 is the slant asymptote. Slant asymptote. For this function, x is equal to minus 1 vertical asymptote having vertical asymptote, and y is equal to x minus 1 is slant asymptote having these two. So now coming to the graph, before going to graph, at x is equal to 0, then f of x 0 how much? 0 by 0 plus 1 is equal to 0. So this curve passes through the origin 0.0, 0, 1 point on the curve. So take the x-axis and y-axis. This is the x-axis, this is the y-axis, negative x-axis, negative y-axis. Now x is equal to minus 1. Suppose here x is equal to minus 1 here. And y is equal to x minus 1. What about y is equal to x minus 1? Suppose this is x, y. If x is 0 and y is 0, then what coming? If x is 0, y is equal to minus 1. If y is 0, x is equal to 1. This is the origin. This is the 1, suppose. This is the minus 1. And y value minus 1 here. Minus 1. So point here this y is equal to x minus 1 intercepts these 0 comma minus 1 1 and 1 comma 0 1. These are intercepted. 0 comma minus 1 this point, 0 comma minus 1 this point, 1 comma 0 this point. So that line passes through this here and here. This is the y is equal to x minus 1 straight line. Okay. Now that graph passes through the origin. This is the 1 point. This function or curve passes through the origin. And this asymptote. So from this curve passes through this and near to asymptote. This asymptote up to infinity. This side infinity, this side infinity. And at the same time, this is also subdivision 3 problem. F of x is equal to 3x by x square plus 2 under root given. Here we find the vertical asymptotes and horizontal asymptote and slant asymptotes. Limit here denominator should be equal to 0. It is infinity coming. So suppose x square plus 2 is 0. Is possible or not? If this is 0, infinity coming. So x square plus 2 is equal to 0 is not correct. No suitable for all real values. If x belongs to R, So this value is always positive coming. So is not equal to 0. X belongs to R, x square plus 2 is not equal to 0. That's why there is no vertical asymptote. Vertical asymptote. There is no vertical asymptote. Now we check horizontal asymptote is there or not. Limit x tends to infinity. F of x is equal to limit x tends to infinity 3x by under root of x square plus 2. So in the infinity case, here maximum power is x power 1. So we divide with the x. Otherwise you take here x square common outside, 3x by under root of x square common, here 1 plus 2 by x square. After this it is equal to 3x by root of x square. This separate here, root of x square and the root of 1 plus 2 by x square. Whereas limit x tends to infinity, here also limit x tends to infinity. So here root of x square, root means x square, here mod x coming, 3x by mod x root of 1 plus 2 by x square. So limit x tends to infinity, here if mod x is equal to plus x, if x greater than 0, if mod x is equal to minus x, if x less than 0. So if x is negative, this is also negative, x is positive, this is positive. So limit x tends to infinity, 3x by consider plus x and the root of 1 plus 2 by x square. So x cancel, so x tends to infinity, here 0, so 3 only 3 coming. After that minus x give that, if limit x tends to infinity, 3x by minus x root of 1 plus 2 by x square. So here x cancel, x tends to infinity, here 2 by x square, this is 0, 3 by 1, this plus 3. And here minus x consider, minus 3 coming. So here y is equal to 3 and y is equal to minus 3 are two horizontal asymptotes. So there is no slant asymptote. Why? Because you got here power x 1, here also x square and root power 1. Degree both are equal. There is no slant asymptote. One asymptote, this is also one asymptote. In between this curve, if we consider f of minus 2 value, some value coming here. Okay, if you have minus 2, minus 3, minus 4 like that, if we give the negative values left side, this curve passes through like this up to infinity, this also. Anyhow, this is the graph about the given function. Next graph. So before this, mod x square under root coming, this is plus x. Otherwise mod x, this meaning plus x if x greater than 0, mod x is equal to minus x, x less than 0. This meaning what? 0, x, so this is the y, suppose y is equal to plus x, y is equal to minus x, y is equal to x like this is the y is equal to x, and y is equal to x minus x this side, this is the y is equal to minus x. So x negative, x positive. In this case, this graph coming, y values. After that, y is equal to 3 and y is equal to minus 3. Two horizontal asymptotes are there. This is the y is equal to 3 above, y is equal to minus 3 below. This is the y is equal to minus 3. So what about the asymptotes? If substitute x is equal to 0, here f of 0 what coming? 3 into 0, 0, here 0, but 0 by something 0, 0 coming. So this curve passes through the origin. This passes through the origin. And what about the curve? This is the asymptote and passing through point, so it will reach to this positive side. And here this side. So this is going to touch at infinity point, minus infinity point. That's why this is the asymptote horizontal. This is horizontal asymptote. Total. It passes through the origin 0, 0.